Welcome back to the C++ Bootcamp. We had an opportunity the last time to look at a particular programming solution, and I thought what I'd like to do now is, instead of throwing a lot of things together, let's slow down a bit and talk about looping structures. So we kind of talked about looping, but what I want to do is just dive a little deeper. Let's go through some fundamentals and actually write a couple of programs that leverage them. So first off, let's just remember program development is all about making sure that you take some input, do some processing, and then you end up with some output. This is the same for all programs, every program. So if you think about anything, the programs your phone runs, the programs that are in your car, the programs that are used for GPS, all of that stuff. It takes some input, does some processing, and gives you some output. So we talked about what the looping structures actually are. And let me remind you again, you have the for loop, the while loop, and the do while loop. Now, each one of these is used for different purposes, even though they serve the same end. So I guess the first question would be, why would you use looping? What do you need it for? So if we were to write a simple program that okay, so let's say we've got a student, or actually we have a class of students. So we talked about arrays. Arrays are just collections. So in this case, we will do student tests. So if we've got 30 children in the class and they've all got different scores for their test. The first thing we would do, I guess, is let's just initialize these. But okay, so the first thing, remember, is we've got our array, and it's an array because we use the brackets with a number to give us the number of elements, and then we initialize it so that each one of the locations in the student test array is going to be set to 0 at first. And because it's a float, let's go ahead and make each entry be 0.0. A small aside, when you're talking about an integer, you don't have a decimal. So integers are like 10, 20, 100, 200, etc. With floats, you do have a decimal place. Actually, you have a few of them, and that's because you want to be more precise with your actual numbers. So not to get off topic, but there you go. So you got the integer and you have the float. And in our case, we want to have a collection of floats so that we can figure out the average test score. So if we had a function that, let's see, so the point of this function is just to give us the average. So student score average. And in order for this to work, we would give it a pointer to the float collection. So student tests, well, actually test score container, something like that, right? And then we would also say maybe a number of students. And this is to make sure that we can, let's see, number of students, so student count, so that we can actually do the average properly. Now, the next thing that we would do is, what I was going to say is, instead of taking student tests and adding scores one by one, we're going to use a loop to do that. So we will use a for loop in this case. And the reason we're going to use a for loop is because I want to iterate but I want to iterate in a way that allows me to make the iteration automatic. So if you remember when we were talking about that, we said that you've got the initializer. So we say, let's see, so student S is 0. S is less than 30, which it's because we've said that we'll have 30 student test scores. Then S plus plus, just to make sure, or plus plus S, if it's fine. Because what we want to do is we're going to give each student a score. And instead of having to assign them one by one, we're going to use a for loop to make that happen. And we'll say student tests at some location for that. So the student at this location is going to have a score. And let's see, so we'll base this score. How do we do this? Okay, so let's just say we give everybody the same score. So everybody got an 85. And we want to make sure that we use floats so that it's precise. Now, notice with, what is this? 4 lines of code, I'm able to take the student test container and add a score for each student. So if I wasn't going to use a for loop, then I'd end up having to do something like this. I'd have to say student tests at location 0 is equal to some number. And then student tests at some different location is equal to some number. So the same kind of thing. And we would keep going until we got all 30 students. And it's too tedious to do it that way. So that's why we decided to go with a for loop. Now, this is a simple example, but it illustrates one of the useful features of having the ability to do this kind of iteration. And if we step back for a minute and think about the pattern of a for loop, the actual for loop, you have the initialization section, the condition that's going to decide if you're going to continue the loop or not, and then the I guess like the iteration step, for lack of a better term. And if you think about what I've done here and then compare it to what we've got down below, because we only need one index into the student test array, we've done one initialization. And because we want to iterate until we've dealt with all 30 students, we've got this condition that ensures that we're going to go through all of the student test locations and assign a value of 85. And then finally, we have the iteration step that says, okay, at the end of every loop, I want you to increment the value of S. And the initialization only happens once. So every time we go through this for loop, we're going to check the condition, and if it's true, we're going to do what's on the inside here, and then we're going to increment the value. Now, once we get comfortable enough with C++ and start looking at what the assembly language actually looks like, you'll see how the for loop gets translated into some of the lower system level representation that is actually what gets executed when you run a program. But okay, so in the meantime, we've got our for loop, and this is just for initialization. So we would want to give a comment that says initialize the student test scores. And then now that we have these test scores, and they're all 85, of course, now we can actually call our student average. So we would do a printout of the average. So student test score average is equal to, and then all we have to do is just call the function. So student score with our student tests and our size of the number of students. Excuse me. So what we're expecting is that we'll be able to do the cout, and then we will get back the student score average. Now, we used a for loop for the initialization, and we're also going to use a for loop to figure out what the average is. So calculate student test score average. And in order to make that happen, we'll do another for loop, and we will return the test average, or test score average. Now we don't have that defined yet, so we're going to go ahead and define it. Now, if you remember how an average works, the average is it's the sum of all of the test scores divided by the number of test scores. So we need a total also, and then we're going to use that total to calculate the average. So what we're going to do is we're going to do what we did the first time. So unsigned net, we only need one index, and we have a condition that says while we haven't gone through all 30 of the student scores, and then we're going to do an increment, and we're going to say test score total plus equals the test scores at S, and that should give us the full total. And then after we've gone through the loop, now we need to figure out what the actual average is. So in order to get the average, we're going to say that that is equal to the test score total divided by student count. And that should give us the average, which is going to be 85. And the other thing is, since we already know how many students, because we passed it in, we're going to do it. We can replace that 30 with the student count variable, since the parameter was already passed in when we made the call here. So now, like we normally do, let's do a build and see if this works like we expect. So we'll set a breakpoint here, which will stop right before we do the actual call. We will set a breakpoint here that'll let us see that we've got what the total is and what the average score becomes. And then we should be able to wrap up this particular video, because the next video is going to look at the while loop. But okay, so let's see what we've got now. And hopefully we get what we want without having to fiddle around with the code, and in case I made some mistakes. I hope I didn't, but that's how it goes sometimes. Things that seem simple, you end up leaving something off, and then it doesn't work like you expect, and you have to debug it, and that's okay. Okay, so so in our debugger, we've got our locals, which means the things that are local to the locally defined parameters that were provided to the function. Now the auto is our student test collection. So notice we've got a bunch of entries in the array that are all equal to 85.0, and that's to make sure that we get a precise average. So if we continue, we've already gone through the total score calculation, and we see that we've got a total score here. Now we're going to figure out what the test score average is, and that again is going to be equal to the test score total divided by the student count. Okay, so now our test score average is 85, like we thought it should be. And with that, we can continue, and that should be it. But now, because I set the breakpoint here and not at the return, we didn't get to see what the value was when we did the printout. So let me take this breakpoint away and do the debug again, but this time it's going to go through all the steps, it's going to print to the console, and we'll be able to see that the student test score average is 85. Now, if we wanted to just make sure that what we have for the, make sure that we're doing the right thing with our floats, we can change this value so it's not 85.0. So maybe 85.65. Somehow everyone managed to get the precise same score. But then let's make sure that we take this value and tell it that we need to cast to a float. I mean, we're getting back a float, but we want to make sure that the system continues to print it as a float and doesn't try to do us any favors by converting to an integer. There we go. Truncation from double to float. Yes. Okay. So that hopefully that doesn't mess with it too much. But let's see. So that means that we lose some precision though when we see that kind of warning. Okay. Yeah. So that's not that bad at all. And so for this particular session we're done. So the point here was to just talk about the for loop, talk about what you can do with it. Now, things to be mindful of though are if you got a for loop and you don't have an initializer, that's okay, but you need to do the following. So if you don't have an initializer, but you have a condition, then you're almost talking about a while loop. So you see how things turn red, and that's because it doesn't know about this variable anymore. So the way to fix that, if you needed to do it this way, even though I mean it's non-standard, but you could define it outside, and then it would still work like you expect. But hopefully this video has been useful and it helps you understand a bit more about the for loop. Now the next video we'll get into the while loop. And you'll see that they're similar, but a little different. And you would use a while loop in certain conditions. You would use a for loop in other conditions. And we'll see what those situations are as we get into it next time. Thank you for watching. If you found this video useful, please like. If you'd like to follow what I'm doing and see how we progress over time, please subscribe. And as always, if you have any questions or comments or you'd like me to do things a little differently, please leave comments. Don't be afraid to, and I'll try to address them as best I can. Thanks again, and see you next time.